So welcome back viewers. This is my second lecture on transportation problem. So under this lecture you will be able to learn how to solve a transportation problem by northwest corner rule method. Friends, now it's sincere request to all of you, if you have not watched my lecture number 1 of transportation problem, so please go and watch lecture number 1 on transportation problem so that you can easily understand the practical problem, because the practical problem may not be understood by having the knowledge of formulation of mathematical formulation. If you know the entire mathematical formulation of transportation problem, you can easily proceed with the practical problem. Okay, let us begin with the first technique of transportation problem is northwest corner rule method. Friends, here there is a question on board. From the given transportation problem, find out total cost. We have to find total cost and the status of VFS and give you our comment. Conclusion. The three things we have to find out from this question. So, given transportation problem. This is the given transportation problem. Here you have origin and destination. How many origins you have? You have 3 origins. This is origin 1, origin 2, origin 3, destination 1, destination 3 and destination 2 and destination 3. Likewise 3 origins, 3 destination. See, origin 1 is having 10 available quantity to supply. Number of units available in the origin 1 is 10, origin 2 15, origin 3 20. Likewise destination, the demand of destination 1 is 20, demand of destination 2 another, this one 20 and the third one is 5. And these are this one matrix numbers. This is nothing but cost. This is nothing but the cost. See, first of all, the matrix should be a cost matrix. If it is profit matrix, we have to convert into cost matrix. Otherwise, we will not proceed with any of the techniques of transportation problem. Either northwest corner rule method, matrix minimum method, or one. Fine. Now let's this one go with the solution here. This is the solution, right? Fine. Now the question is having destination, origin. Okay, we'll copy this origin and this is our destination. So there are 3 origins. I write O1, O2, O3 and we have demand in the question. So I write demand here. Correct? So likewise there are 3 destination D1, D2, D3 and supply. Okay, I write supply. Fine. Now, fine. The cost of D1 columns are 8, 3, 4, 20. 8, 3, 4, 20. 6, 5, 8, 20. 6, 5, 8, 20. 4, 4, 7, 5. 4, 4, 7, 5. Likewise, here I write supply 10, 15, 20. 10, 15, 20. Right? Then the demands are 20, 25. It is already written. Fine. This is our question. Now the first step, we have to check this given transportation problem is cost problem or profit problem. Whether cost given or profit given. Already the given matrix is in the cost. This is nothing but the cost. Less numbers are there. If you could find maximization here it is nothing but profit. So in this question you have given the cost. No need to worry about profit. So straight away you consider these numbers as a cost. Fine. Now, there are the general steps before northwest corner rule original steps. Three general steps are there. Which are those three general steps? Number one, you convert AI supply into AI. Let supply be AI, let demand be BJ. Fine. Then you separate this. Now, supply got separated, demand got separated, and this is nothing but your matrix. Correct? Now the third step. First step, allocation of AI and BJ. Second, separation of supply, demand, and the third one is balancing. What is the number here? AI side 10 plus 15 plus 20. It is nothing but 40. Okay, I write 40 here, whether it is 40 here or not. Sorry, 20, 20, 45, and here it is 45. Okay, 10 plus 15 plus 20, 45. 20 plus 20 plus 5 equals to 45. This is called as balanced transportation problem. Which problem? Balanced transportation problem. Balanced transportation problem is a transportation problem where AI equals to BJ. AI equals to BJ is called as balanced transportation problem. Okay, these are the basic three steps. First step, allocation of AI and BJ. Then the second general step, separation of AI and BJ. And the third one is calculation of AI and BJ. Both the side, AI side, BJ side. It should be equal. If it is unequal, if it is not equal, we have to add dummy row or dummy column by zero cost element. I will explain you imbalance transportation problem in next lecture. Fine. Now, northwest corner rule method. How to find out the northwest? See, this is the north, this is the north, this is west, this is south, and this is east. We do not worry about east and south. We need to find out northwest corner. Which is the point called northwest corner? See, if I draw box like this is our matrix, this is the north, this is the west, and the corner point is this. So, like this, it is north side and this is west side, and the corner point is this 8. Fine. So, the starting point is 8, from where we have to start our northwest corner rule point by northwest corner rule method. So, we have to consider 8 in the matrix element. Fine. If we select 8, so AI side we have 10 and BJ side we have 20. AI side we have 10 and BJ side we have 20. Sorry, 5. 10 and 20, which is the least? 10 is the least. Allocate 10. Cancel 10. Cancel 10 in 20. 20 minus 10. 20 minus 10 equals to 10. Now we have to compare this AI BJ. 10 and 15. 10 and 15. 10 is the least. 10 and 15. 10 is the least. Allocate 10. Cancel 10. Cancel 10 in 15. 15 minus 10 equals to 5. 5 and 20. 5 and 20. 5 is the least. Allocate 5. Cancel 5. Cancel 5 in 20. 20 minus 5 equals to 15. 15. Now 15 and 20. 15 and 20. Allocate 15. Cancel 15. Cancel 15 in 20. 20 minus 15 equals to 5. This 5 and this 5 both are this one same balance and allocate remaining 5. This is the northwest corner rule steps. Steps of northwest corner rule after general 3 steps. First general step, allocation of AIBJ. Second, separation of AIBJ. Then totaling balancing of AI and BJ. And the first northwest corner point, likewise you have to complete. These are the steps of northwest corner rule method of transportation problem, my friends. Next we'll find out total cost. Okay, here we'll find out the total cost. Roman number 1, determination of total cost. Determination of total cost. Right. So this would be our heading. So there are origin and destination. The first column would be origin, and the second one is destination. Origin, destination, and the cost. Fine. Okay. See how to find out total cost by allotted cells. See, this is the matrix. Allotted cells are, this is allotted cell, this is allotted cell, allotted cell, allotted cell, allotted cells. These are the empty cell, empty, 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 empty cells. So we have to consider allocated cell or allotted cell. So first allotted cell is this O1 D1. So origin 1, destination 1, 10 8s are 10 into 8 equals to 80. Fine. This is done. The second allotted cell is this O2 D1. We write O2 D1. The multiplication is 10 into 3. 10 into 3. 10 3s are 30. Okay, next allotted cell is this. Origin to destination 2. Origin to destination 2. 5 5s are 5 5s are 25. This is empty cell, leave it, and this is allotted cell. Allotted cell, origin 3, destination 2. Origin 3, destination 2. 15 8s are. 15 8s are. It is 120. 120. Next one is O3 D3. O3 D3. O3 D3. 5 7s are. 5 7s are 35. 35. Okay, this is our total cost table. The table of total cost. So these are the 3 different columns you have to draw in your examination. Right? Fine. Here you write total cost. Right? 30 80 25 120 and 35. It is 304. Okay, so this is total cost. Then you find the second one is determination of the status of BFS. The status of BFS or non-degeneracy. Fine. What's the formula to find out the BFS? To find out the BFS, there is a formula m plus n minus 1. This would be the formula. M stands for number of rows in the matrix. N stands for number of columns in the matrix. So n is nothing but row. How many rows are there? Row 1, row 2, row 3. So m is nothing but 3 and n is nothing but 1, 2 and 3. 3 plus 3 minus 1. So 6 minus 1 equals to 5. 5. Now we have to compare this 5 with the allotted cell. Now we compare this n plus n minus 1 with the allotted cells. How many allotted cells are there in the matrix? We have to check. This is allotted cell, allotted cell, allotted cell, allotted cell, allotted cell. 1, 2, 3, 4, 5. Okay, there are 5 allotted cells. It means 5 is equals to 5. Both are same. 5 equals to 5. Now we write the conclusion. The third one is the conclusion. The final one, our conclusion is since m plus n minus 1 is equals to the number of positive allocation, hence the initial solution is basic feasible solution or non-degeneracy. See, this is our conclusion. So according to the question, we calculated total cost, we calculated the status of BFS, and our comment since m plus n minus 1 equals to the number of positive allocation, hence the initial solution is basic feasible solution. Why it is basic feasible solution? Because m plus n minus 1 equals to the number of positive allocated cells. This is all about the method of northwest corner rule method and the transportation problem. Friends, if you have any doubt, any this one query, you feel free to comment. Okay, I will read your comment and I'll respond to you. Thank you so much. Have a good day.